Okay, in this tutorial, I'm going to walk through the entire process of graphing a rational function. I'm going to do two examples. One's going to be a little more involved than the other one. The first one we're going to take a look at is how to graph the rational function 5x over the quantity x squared minus 1. Now, in both examples, I'm going to walk through the steps, and you'll notice that the steps are not going to change depending on the difficulty. So if I get in the habit of following these steps I've outlined, these 6 steps, every single time, then you're going to be able to graph these rational functions. So step 1 says that we're going to factor both the top and the bottom of the rational function. Now in this particular case, there's nothing for me to do on the top. So I'm just going to leave that as 5x. But on the bottom, I have x squared minus 1. I should be able to quickly factor that into x plus 1 and x minus 1. So now I'm factored. Now there's two reasons why we do that. One reason is by factoring it, it allows me to clearly see if there's a common factor in the numerator and denominator, because that creates holes. You'll notice in step 2, I start discussing holes here. Again, a hole occurs where there's a common factor. And if it's in factored form, I can clearly see that. The other reason why I want to factor it is it's going to make finding the vertical asymptotes and the x-intercepts easier. So in this case, since I do not have a common factor in the numerator and denominator, I do not have any holes. So I'm just going to write in step 2, none. I have no holes in this particular example. So I'm ready to move on then to step 3, which is find the vertical asymptotes. We set the factors in the denominator equal to 0 and solve. So my factors in the denominator were x plus 1 and x minus 1. So I'm going to solve both of those. So on the left, I get x equals negative 1. And on the right, I get x equals positive 1. So my two vertical asymptotes are negative 1 and positive 1. And I'm going to go ahead and graph those. So I'm going to use dotted lines at x equals negative 1 and at x equals positive 1. So I'm going to do a dotted line at negative 1 and a dotted line at positive 1. Remember, asymptotes are always represented with a dotted line on the graph. Now let's move on to step 4. Step 4 is to find the vertical or the oblique asymptote. Now remember, horizontal and oblique asymptotes are found based on what the degree of the numerator and denominator are. So what I'm going to do is I'm going to go back up to the original equation, and I'm going to highlight the degrees here. It's always easiest to go back to standard form. My degree on the bottom is 2. My degree on the top is just 1. So since the degree is higher in the denominator, that means my horizontal asymptote is y equals 0. Let me say that one more time. When the degree is larger in the denominator, the horizontal asymptote is always y equals 0. Now, the other cases for horizontal and slant asymptotes, I go over in another tutorial. So if you need to take a look at that, go ahead and do that. So once again, I'm going to graph my horizontal asymptote at y equals 0. Now we're ready to do the intercepts, the x-intercept and the y-intercept. To find the x-intercepts, I set the numerator equal to 0. In this case, my numerator was 5x. So I'm going to set 5x equal to 0 and solve it. So I get x equals 0. So that's my x-intercept, 0, 0. To find the y-intercept, I'm going to evaluate f of 0. In other words, set the x as equal to 0. So if I do that, I get 5 over 0 and 0 squared minus 1. So that gives me 0 over negative 1, which is 0. So my y-intercept is 0, 0. So let's go over to the graph and notice how they're the same in this particular case, 0, 0. So I'm going to plot that point. Okay, now at this point, the way you're going to handle this depends on what your teacher wants you to do. So for step number 6, I say graph the function using a calculator or a table of values. Some teachers are going to want their students to actually make a table of values. In other words, just start picking x values, -2, -3, 4, 10, whatever. And you're going to plot points based on your table of values. What I'm going to do is I'm going to use the graphing calculator to help me put this together. So I've already taken a minute to graph this, and what you're seeing right now is the graph of this function 5x over x squared minus 1. And what I'm going to do is I'm going to basically just drag my mouse along this graph and try to find a few key points. And you can see that most of these are not very clean looking. So I'm just going to do as best I can. I have -4 and -1 1/3. So let me plot that. -4 and -1 1/3. So I'm going to go over to -4, go down, and I'm just eyeballing it. So right about there. Let me try to pull another point. Maybe -2 and -3 1/3. So right about there. So that's enough. So now what I'm going to do, I'm just going to draw in my curve. So I'm hugging the horizontal asymptote, go through those points, and then I'm going to hug the vertical asymptote. Now the middle of the graph makes kind of like a -x³ graph. So I'm just going to trace that. So I'm going to follow the vertical asymptotes, and then I'm going to go through the origin and then hug the other vertical asymptote. And then just to speed this up a little bit, I'm going to do the same thing on the right that I did on the left, which is just pull a couple key points and draw a rough sketch. So 2 and 3 1/3. And then 1, 3, 4, basically 4 and 1 1/3. And then I draw in my curve. So guys, the one thing about this is we're never going to be able to have a really accurate graph because so many of these points are ugly. It's really just eyeballing the points as best we can, but focusing on the key characteristics, the asymptotes, the x-intercepts, and the y-intercepts, and the holes if you have those. So that wraps up the graph 5x over x squared minus 1. Now let's go into another example, which is this one, 2x squared plus 5x minus 3 over x squared minus 9. Now I'm going to start the same way I did the other one, which is to factor it first. So the top is going to factor into 2x minus 1 and x plus 3. And if you need to revisit factoring, by all means do that. You have to be able to factor to do these rational functions. Okay, so I factored it. Now, the difference between, and this is a plus here, sorry about that. The major difference between this one versus the one we just did is there is a common factor. Let me highlight that. Notice how there's the common factor x plus 3. Therefore, a whole is generated by that common factor. So let's go to step 2. Since I have a common factor x plus 3, I'm going to set that equal to 0 and solve it. So my whole is occurring when x is -3. Okay, so my whole, again, is occurring when x is -3. However, a whole is a point. So I'm only halfway there. I know the x value, but I need the y value. So what I'm going to do is I'm going to substitute in -3 to what I call the simplified equation. The simplified equation is 2x minus 1 over x minus 3. So I'm going to now take -3 and put it into that simplified equation. So if I do that, I'm going to get 2 times -3 minus 1 over -3 minus 3. So on the top, I'm going to get -7. And on the bottom, I'm going to get -6. So therefore, the y value of the whole is 7 over 6. Now I'm going to go ahead and plot that on my graph. I have to do a little estimating. So I'm going to go -3 And then 7 over 6 is basically right about here. So I'm going to make a little hole right there. So negative 3 and 7 over 6. I'm just eyeballing that as best I can. Now let's keep on going. At this point, the function we are going to focus on is this one. I tell students, look, just ignore the previous one because now that I've taken out that common factor, I just want to focus on that simplified equation. Now my vertical asymptotes, just like before, I set the denominator equal to 0. So my denominator is x minus 3. Set it equal to 0, and I get x equals 3. And let's plot it. So x equals 3, dotted line. Dotted line x equals 3. Now, slant versus oblique. Look at my degrees. I have a degree of 1 on the top. I have a degree of 1 on the bottom. Therefore, my horizontal asymptote is the ratio of the leading coefficients, which is 2 over 1, or just 2. So now I can draw a dotted line at y equals 2. And now I'm ready to find x and y intercepts. So to find the x-intercepts, you set the numerator equal to 0. Let me go back up and see the numerator. The numerator is 2x minus 1. So 2x minus 1 equals 0. So I get x equals 1/2. And we're going to write that as a point, so 1/2 comma 0. For the y-intercept, I'm going to do f of 0. So on the top, I get negative 1. And on the bottom, I get negative 3. So my y-intercept is 1/3. Remember, I'm going from that simplified equation. So I'm going to eyeball both of those. So 1/2 and 1/3. So 1/2 on the x, 1/3 on the y. And now I'm going to use the graphing calculator. So again, let me just kind of recap what we did. We factored. We found the common factor to create the whole. We found the vertical asymptotes by setting the denominator equal to 0. I found the horizontal by looking at the degrees. I found the x and y intercepts, and now I'm going to use the graph. So I've already graphed this. It's this blue one right here. And I can see if I toggle over the y-intercept, see how it's 1/3 just like we said. The x-intercept is 1/2 just like we said. Now I want to go over to negative 3 where we said the whole was. As I follow this line, take a look. When I get to negative 3, it's blank because there's no value there. So I don't actually see the whole on the graph, but it's there. Okay? So that's why it's so important that we understand how to do this stuff by hand, because some of this stuff isn't going to show up on the graph. Like I don't even see my asymptotes on the graph, but I know that they're there. So now what I'm going to do is I'm going to draw in my shape. So I'm hugging the horizontal asymptote. I go up to the whole.